Okay. The next thing we need to do is create a mesh for our part. And in fact, we need to create at least two meshes, maybe three, to check whether whatever solution we get depends on the mesh. But first, we'll just create a mesh. So to create a mesh, the next thing you do is click on the mesh menu. It'll have some defaults here of how it wants to create your mesh. Sometimes sometimes it's not a bad idea to let it just generate a mesh automatically. But I personally like to have a little bit more control over how it does things right from the get-go. So for example, I said that there are features on here that I don't actually want to simulate. So like there are these little gaps in here, and if you leave these little geometric features, if you allow the mesher to do what it wants to do, it will actually insert some very tiny elements there to try to capture that geometric feature, which I really just don't care about, and it's really just a waste of mesh elements. So I think I said when in the setup that I'm really only interested in feature sizes that are over like 100 microns. So that would be like 0.1 e to the minus 3. And I really am okay with it ignoring features smaller than that. Here's another thing that you will generally want to set, especially if you have fine ribbed structures like this. I don't really ever want to end up in a situation where I have this thin structure and there's only one element spanning the entire thing. And I also don't really want to end up with features where I have one element that spans, all the way up to like, let's say half the height of this. Like high aspect ratio elements are bad as well. I'm generally going to ask that there be two elements across this gap. That's usually best practice, but it's not required, but it's what I want. So I'd like to make sure that I have enough, resolution in the temperature field to capture those kind of changes. And the global gradation rate is basically how much, this is like what factor a element can be bigger than an adjacent element. So like this means that one element can be up to 22% bigger in length than an adjacent element. That ensures that your elements aren't growing so fast that some of the approximations used to do the interpolations become bad. This is a bigger deal for the finite volume method than it is for finite element method, but it's still something you want to kind of keep control of. I think the default here is actually pretty good. I don't generally have an issue with that. It will, now, the key thing you might be thinking about is like, how big do you want the elements to be? SimScale uses what it calls fineness as like if you're using the automatic sizing algorithm, it just has a number between, I think it's between 0 and 10. I have yet to actually figure out like the formula that determines what that number corresponds to in terms of element size. So if you have a specific thing you care about, you might want to turn it to manual and actually specify the maximum edge length of elements that you want. I actually think that the automatic mesher usually does an okay job, but sometimes you may have to add additional controls later. For the moment, what I'm going to do is just I'm going to leave this mesh that way, but what I'm going to do is I'm going to add a refinement. There is one specific region that I do want to make sure that I have lots of elements for, and that is these bottom heaters. So because these are volumetrically heated, I kind of know that there could be up to a parabolic distribution of temperature inside of in this region. There's some sort of more fine temperature gradient variations going on. So what I'm going to do is I want to make sure that I have a lot of elements in this region over here, or at least a decent number. So to do that and do it just in a particular region, you can use what's called a mesh refinement. So down here, what I'm going to do is I'm going to select a region refinement, which is going to allow me to select a volume. Maybe, in fact, I'm going to select two volumes because these two volumes are quite similar. And what I'll do is inside that particular region, I am going to specify the maximum edge length. So in this case, I know that this element is about, well, let me put it this way. I've already guaranteed that I'll have at least 2 elements across this gap by using a gap refinement measure. But if I want to have more than that, let's say 4 across this gap, then I might need to specify a quarter of whatever this edge length is. So let's see. So that would be, so let me remind myself, how big was this? This was 2.5 millimeters long. So let's say I want to have, I don't know, maybe 5 elements. So that would be, oh, let me do this math. Okay, sorry. It'd be easier for me to just get a calculator. So I wanted this to be 2.5 millimeters. So let's say I want to have like 4 elements. So I want to have like an edge length that's something like, 0.6 is like the element that I want. So I'll type in like 0.7 here just to allow it to extend itself a bit. So that'll be the maximum edge length that I'll allow in that region. And that's going to guarantee that I have a decent number of elements in that region. After I see the mesh, I may not actually want that many, but that's what I'm going to specify. And then I'll ask it to generate the mesh. Before you do that, it's a good idea to take a look at how many core hours it estimates that's going to take. So it says it's going to take about 2 core hours. So that means that unless it uses a lot of computing cores, this could actually take a while. I actually don't think it's going to take as long as it thinks, but I'm going to go for it here. I'm going to just click generate and see how long it takes to generate. And let's just see how it does.